Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Electrophilic aromatic substitution, EAS, in indole preferentially occurs at the most electron-rich position. In indole, the nitrogen lone pair donates into the pyrrole-like ring, making the C3 position, in standard indole numbering, the most activated. However, looking at this specific structure and its numbering, the molecule shown is an indole, or isondole, system where NH connects to benzene rings. The nitrogen donates electron density via resonance into the ring. In indole chemistry, EAS occurs preferentially at position 3, the beta carbon of the pyrrole ring adjacent to nitrogen. In this problem's numbering scheme, position 1 is on the carbon directly adjacent to nitrogen on the right-hand ring. The nitrogen lone pair resonance activates position 1, alpha to N, strongly. Reasoning, the NH nitrogen in the 5-membered ring donates electrons via resonance. The alpha position to N, labeled position 1 in this structure, is highly activated toward electrophilic attack because the nitrogen lone pair directly stabilizes the positive charge in the valent intermediate at that position through resonance. The CH3 group at position 2 further activates the ring, but the primary activation is at position 1 due to direct nitrogen lone pair donation. Why other options fail? Position 2 has a CH3 substituent activating, but the position may be blocked or less activated than position 1 for EAS due to steric effects and the primary resonance directing to position 1. Positions 3 and 4 are on the benzene ring fused to the nitrogen-containing side. These positions are less activated compared to position 1, which is directly alpha to the nitrogen atom where nitrogen lone pair resonance is most effective. Therefore, the correct answer is A. Therefore, the correct answer is option A.